Assalamu alaikum. In this video, I will explain the lesson 2 of chapter 13 alkanes. The objective of this lesson is name a branched chain alkane according to the IUPAC. Before starting, we have to recall some information of the previous lesson. In the previous lesson, we studied that hydrocarbons are organic compounds made up of carbon and hydrogen only. And saturated hydrocarbons are classified as saturated because all the bonds between carbon atoms are single covalent bonds. The general formula of straight chain and branched chain alkane, which is a saturated hydrocarbon, is Ch13 plus 2, and the branched chain alkane is made up of two parts, the main chain and branches, which are the alkyl groups, and the general formula of an alkyl group is CnH2n plus 1. This is an example of a branched chain alkane. But how can we name a branched chain alkane? To name a branched chain alkane, we have to follow the step given by IUPAC System. IUPAC means International Union of Pure and Applied Chemistry. The IUPAC system helps us to give the nomenclature or the systematic name of a branched chain alkanes. The first step to follow is to choose the main chain, the longest one of the alkane, the one that contains the greatest number of carbon, and name it. To understand these steps, we have to apply each one on the following alkane of a branched chain. So the first steps ask us to choose the main chain. So to choose the main chain, we have to count carbon atoms. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7. So it seems that this one is the longest chain. We have to give its name since it contains 8 carbon atoms, so it represents the octane. Now, the second step, identify the branches, alkyl groups, and name them. In the first step, we choose the longest chain. All the groups that are attached to the main chain are considered as branches. The first one contains just one carbon atom, so it's methyl group. The second one contains 2 carbon atoms, so it's the ethyl, and the third one it's also methyl since it contains just 1 carbon atom. The third step is number the main chain so that the carbon carrying the first branch has the lowest possible number. What do we mean by this step? Here we have to choose 2 directions. The first direction, for example, starting by this extremity, this is the first direction. So this one represents in this case the first carbon, and the first branches, which is the methyl group, here we have 2 methyl groups, are attached to the carbon number 3 according to this direction, and the ethyl group is attached to carbon number 5. So following this direction, we get the 3 numbers, 3, 3, and 5, where each of these numbers represents the position of the ramification or the branches or alkyl groups in this case. If we change the direction, so in this direction the first carbon is this one, and the first branch is attached to carbon number 4, while the 2 other branches are attached to carbon number 6, and we get the numbers 4 for the ethyl group, the position of the ethyl group, and 6, 6 for the position of each methyl group. But referring to the step, to the rule, we said that we have to number the main chain so that the carbon carrying the first branch has the lowest possible number. Here is the carbon carrying the first ramification or the first branch, and here is the carbon holding the first branch. So we have to choose this one because the number of carbon in this case is the lowest one, and we cannot follow this direction. The fourth step, write the index of the position of alkyl groups that meet the number of the carbon atom to which the branch is attached, followed by a hyphen or dash that separates it from the name of alkyl group. So we have to write the position of the alkyl group as a number, and we have to put a dash between the number and the name of alkyl group. Numbers are always separated from letters by hyphens, and then followed by the name of the main chain. So the name of alkyl group is followed by the name of the main chain. There is no space between the last name of the alkyl group and the name of the main chain that follows it. There is some remarks to respect when giving the name of a branched chain alkane. In case of the presence of different branches, as our case we have ethyl and methyl, name first the group that its name starts by a letter which comes first according to the alphabetic order. Here we have methyl M and ethyl E, and the letter E comes before letter M in the alphabetical order, so we have to give the name of ethyl before methyl in the name of the alkane, and then name the others following the alphabetical order. The second remark, if many identical alkyl groups are attached to the main chain, as our case we have 2 methyl and 1 ethyl, a prefix is added to the name of the alkyl group according to the number of branches. For example, if we have 2 methyl, we add dimethyl, we said. If we have 3 ethyl, for example, we said triethyl, 4 tetra. The last remark, according to IUPAC, numbers are separated from each other by commas. Between 2 numbers, we have to put a comma. Now, according to the remarks and to all the steps that we explained before, we have to give the name of this branched chain alkane. Look, first of all, we have to start by naming ethyl because E comes before letter M in the alphabetical order. So the position of ethyl is on carbon 5. We said 5 hyphen ethyl hyphen 3 comma 3, because we have to give a number for each methyl group and each one is attached to the carbon number 3. So 3 comma 3 hyphen dimethyl, because we have 2 methyl groups, and at the end we have to name the main chain, which is octane, and we get the name of this alkane, which is 5 ethyl hyphen 3 comma 3 hyphen dimethyl octane. As application, we have to solve some parts of exercise number 7 on page 240. For this hydrocarbon, the first step said to choose the longest chain, 1 2 3 4 5 1 2 3 4 5. So this is the longest chain. This one represents the branch, so it's attached to the carbon number 1 2 3 or 1 2 3, so the same number in the 2 directions. So it represents the 3 dash ethyl, and we don't have a space between the name of the alkyl group and the name of the main chain, and pentane, since we have 5 carbon atoms in the main chain. For the second one, we have to choose the longest chain, 1 2 3 4 5 6 7 8 1 2 3 4 5 6 7 1 2 3 4 5 6 7. This is the longest chain. But if we count starting from this atom, we have here 1 2 3 4 5 6 7 8. So we have another main chain which contains also 8 carbon atoms. So which one of these 2 main chains we have to choose? There is a rule that says that we have to choose the longest chain that contains the greater number of branches. So if we consider the main chain marked by red, here we have 1 2 3 4 branches. For the blue one, we have 1 2, and these carbons are considered as 1 branch, so we have 3 branches. So of course we have to choose the main chain which is marked by red color. In this case, starting by numbering the chain from the 2 extremities, 1, 2. In this direction, a methyl group is attached to carbon number 2. If we consider the second direction, 1, 2, 3, 4, so the first ramification or the first branch is attached to carbon number 4, so we have to choose this direction, since in this direction the first ramification or the first branch occupies the carbons which have the smallest number. So here we have 3 groups methyl, so it's a trimethyl, 1, 2, 3, and we have 2 groups ethyl, so they represent diethyl. So we have first ethyl on carbon number 3 and the second one on carbon number 5, so it's 3, 5 dash diethyl dash 2, 2, 3 separates by comma dash trimethyl, and at the end octane 3, 5 diethyl 2, 2, 3 trimethyl octane. For the last example, we have to choose the longest chain, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7. So this is the longest chain. The branches, we have to choose in which direction we have name the branches. Starting by this extremity, we have 1, 2, 3. So the first ramification, the first branch is attached to carbon number 3. Starting from this extremity, 1, 2, 3, 4. So the first branch, which is the ethyl group, is attached to carbon number 4. So we have to follow this direction, 1, 2, 3, 3, 3 dimethyl, and we have 4 ethyl. We have to name ethyl before methyl, so 4 ethyl, 4 ethyl, hyphen between the number and the name, another hyphen between the name and the number, 3, 3 for each methyl group. We have the position separated by a comma, hyphen, dimethyl, here we don't have space, and heptane, since we have 7 carbon atoms in the main chain. Now we will talk about haloalkanes or alkyl halides. Alkyl halides are not hydrocarbons, since we can get an alkyl halide by replacing a hydrogen in the alkane by a halogen or an element of group 7, which can be bromine, chlorine, fluorine, or iodine. So the name of the obtained haloalkane is determined in the same way to that of branched alkane, where halogens are considered as branches and which are named as followed. For bromine, we have bromo, chlorine, chloro, iodine, iodo, and fluorine, fluoro. Here is an example of alkyl halide. First of all, we have to choose the main chain. The main chain must contain only carbon atoms. So 1, 2, 3, 4, this is the butane. And we have here chloro attached to carbon number 2 and chloro and bromo attached to carbon number 3. So we have, if we start by this extremity, we have 2, 3, 3, and if we start by this extremity, we have 2, 2, 3. So here the numbers are smallest, so we have to choose this direction, and we have to name bromo before chloro, since B comes before C in the alphabetical order. So we have 2 bromo, 2, 3 dash dichlorobutane. As application, we have to solve the number 7. Here in this compound, we have just 1 carbon atom, so it represents methane, and we have 2 bromo groups, and this is dibromomethane. In this case, we don't have to indicate the position of bromo, since we don't have different possibilities. The second one here, 1, 2, 3, so this is propane, and the chloro occupies carbon number 2, so 2 chloropropane. For this one we have 1, 2, 1, 2, 3, so from this extremity 2-bromobutane, since we have 4 carbon atoms in the molecule. And for the last one, pause the video and try to give the name of this haloalkane. Now 1, 2, 3, 4, 5, 6. We have 6 atoms in the main chain. We have bromo in carbon number 2, methyl in carbon number 3, and chloro in carbon number 4, and ethyl in carbon number 4. We give the name of bromo. So 2 bromo, 4 chloro, 4 ethyl, and 3 methyl. 2 bromo, 4 chloro, 4 ethyl, 3 methyl hexane. Look, between each number and the name we have hyphens. And this is all for this lesson. In this lesson we studied that we can give the systematic name or the nomenclature of a branched chain alkane according to the IUPAC system and by following these steps. And this is all. Thanks for your attention and for the next time.